was all about the vocab, okay? And just kind of getting familiar with whenever I say vertex, what am I talking about? When I say axis of symmetry and the domain and the range, that's the big important thing from yesterday. But what we're doing today is we're actually going to talk about how to graph a quadratic function. So first thing, I mentioned this super briefly yesterday, but remember a quadratic function is written in the form y equals ax squared plus bx plus c. So the big thing with the quadratic functions, you absolutely have to have an x squared. You don't have to have the bx or the c, but you have to have an x squared. Have to have an x squared. Okay, the rest of it's kind of optional. We'll see examples of all of those today. Okay? So to graph a quadratic function, I mean, really simply put, to graph any function, whether it's a line, whether it's a quadratic function, a square function, anything, I just need points to graph, right? If I had a bunch of coordinates, if I had a bunch of x comma y's, I could put those on a graph, and I'd have my picture, okay? So what we need to learn how to do today is what points that I want to find, because the thing is, you can't just find any points, okay? Because remember, a parabola, if we're talking about one that opens up, it's going to go down and then it's going to go back up. You, in the end, are going to choose what you plug into the function. So you are going to, in a way, choose what points you find, but you have to find the correct points. Because let's say you find not the points you're supposed to find. There are solutions to the function, but if the parabola is supposed to go down and come back up, maybe you only find the points on the left-hand side. And so the picture you're going to see are just the points that are coming down. You're going to miss the whole other side of the picture where the points come back up. So what we have to be able to do is we have to know what points am I supposed to plug in so I get the whole picture. Okay? So really, what I need to know, remember the center of the parabola, right? That middle point of the parabola called the vertex. That's what I need to find. Because if I can find the vertex, I then know, okay, well, here's the area where my parabola is at. Let's plug in points around my vertex. Because around the vertex, it's going to come down on the vertex and then back up on the other side of the vertex. I'm going to see the whole picture. So we have to find the vertex first. And actually, before we find the vertex, what we're going to find first is the axis of symmetry. Because remember, what the axis of symmetry does, okay, it takes this parabola and it cuts it in half. So if I can find the axis of symmetry, okay, if we were to look down here at this, if I can find the axis of symmetry, maybe the axis of symmetry is way over here on the left, which means my parabola is way over here on the left. Or maybe my axis of symmetry is right here in the middle, which means my parabola is right here in the middle. But I have to know whether my parabola is on the left-hand side, the right-hand side, kind of towards the middle. I need to find that axis of symmetry first. So we have a formula for the axis of symmetry, and it looks like this. To find the axis of symmetry, remember, it's a line, and it's a vertical line, which means it's an x equals equation. So you just have to figure out what x equals, and here's how you're going to do that. To find the axis of symmetry, you're going to do x equals, and I know it looks like a negative, but I like to say opposite. Because if it's already negative and you're saying negative, negative, b, that can sometimes get confusing. So we're going to call it the opposite. So we're going to say the opposite of b over 2a. Now we need numbers to plug in for b and a. Here's where those numbers come from. B is always going to be the number in front of your x term. Always. So to find b, the numerator, you're going to find your x term and put the number in front of that. Okay, that's what's going to go up there. And then 2 times a, your a is the number in front of your x squared. So we're always going to have an x squared, so find the number in front of it. That's what's going to go behind the 2. And then you're going to multiply 2 times a, and you're going to simplify. That will tell you where the center of your parabola is, and that is super helpful. After that, we're going to find the vertex, and we'll kind of talk through how we're going to do that. And then, like I kind of explained, once you find the vertex, you know that the parabola either comes down to the vertex and then back up, or if it opens up the other way, you know it's going to come up to the vertex and then back down. But you know where the middle is, so then we're going to find points on either side of the vertex to kind of help complete the picture. So in the end, what we're going to do is we're going to find 5 points, 5 solutions. We're going to find the vertex, and then we're going to find 2 points to the left of the vertex, and then 2 points of the right of the vertex. You can always find more, but for today, we're just going to find 5. Okay? So, if I look at this first one here, okay, we want to graph y equals 2x squared plus 4x. First of all, how I know that this is a quadratic equation, meaning it's going to be a parabola and not a linear equation, is that it has an x squared. Anytime you see an x squared, you already know it's a parabola. It may open up, it may open down, it may be really wide, it may be really skinny, I don't know, but I know it's a parabola. So if it's a parabola, I need to know where this parabola is at on my graph. So I need to find the axis of symmetry. So to find the axis of symmetry, that formula from above says we are going to take x equals the opposite of b over 2a. Okay, and like I said in the beginning, remember that all of these quadratic equations are in the form y equals ax squared plus bx plus c. That's where the a and b come from. So when I'm ready to plug in my numbers, x equals, I need the opposite of b, so I need my b first. Now the b, okay, the b, you need to find your x, just your plain x. Okay, right here. The number in front of it is your b. So for this problem, my b is 4. Now my formula, though, says I need the opposite of b. So if b is 4, the opposite of 4, negative 4. Over 2 times, okay, then I need my a. A is always going to be the number in front of your x squared. So you're going to find your x squared, the number in front of it. So in this case, the 2. That's what you're going to plug in for a. So we have the opposite of b over 2 times a. Does it make sense where I got this number from? Yes. Okay, so the formula that I was given that they told me to use, it says the opposite of b over 2a. Okay, that's what was given to me. So I need to take 2 times a. A is 2, so it's 2 times 2. Yep. So opposite, if it's a positive, the opposite would be a negative. If it's negative, the opposite would be a positive. Yes, you just flip the sign. Okay, then you want to go ahead and simplify this. So you're going to take 2 times 2, which is 4. So it's going to be negative 4 over 4, which is negative 1. Okay, that's the first most important thing you guys have to be able to do. You have to find the axis of symmetry. So x equals negative 1. X equals negative 1, like that. Okay, so what I know now, okay, and don't copy any of this down on your paper, okay? What I know now is I know that this is the middle of my parabola. So kind of picturing what it could look like, that line's going to cut it in half. But here's the problem. I don't know if my parabola is there. I don't know if my parabola is down there. I don't know. I don't know. I don't even know if it goes up or down. The big next thing that I need to know, I need to know where that vertex is at, right? I know that that axis of symmetry cuts my parabola in half, but what I don't know is I don't know up or down where that parabola is at. That's where the vertex is going to be. That vertex is the middle of my parabola. It has to be on that line somewhere. I just don't know where. So the next thing I need to find is I need to find the vertex. Now remember, the vertex is a point. It's an x, comma, y. But here's the thing. If you know your vertex is on this line somewhere, you already know something about this point. Because think about all of the points on this line. This point here is negative 1, comma 0. This point is negative 1, comma 2. This point's negative 1, negative 3, negative 1, 5, negative 1, negative 5, negative 1, negative 1, negative 1, 3. What do all those points have in common? They're all negative 1 comma something, right? So here's the thing. I know that if my vertex is on that line, it has to be -1, comma something. So your vertex is -1, comma something. I don't know what it is. But I at least know the x-coordinate. I know half of my vertex. Does that make sense? Okay. Now I need to find the y-coordinate. Well, here's the thing. I have a rule that tells me how to find the y-coordinate. It's my function. This tells me y equals 2x squared plus 4x. It tells me how to find y. It tells me to do this. So think about the function machine that we talked about back in chapter 4. Into your function machine, you plugged in x values. You followed a rule. That's what this is. And it spit out y values. I'm looking for a y value. And guess what? I have an x value to plug into my function machine. I have a rule to follow. It's going to spit out a y value. So that's exactly what we're going to do. We're going to take our function machine. We're going to drop in a -1. So here's what this is going to look like. Y equals, to find y, here's your rule. You are going to take 2 times, I have an x, right? That's what we're plugging into our function. We're plugging in -1. So I'm going to take 2 times -1 squared. And my rule says then to take plus 4 times x, which once again, anywhere you see an x, this is what we're plugging into your function. You're going to plug in a -1. So all I'm doing here is I'm plugging -1 into my function rule. Okay? And then we're just going to simplify. Now, if you're using a calculator, which is totally fine, if you have a calculator that can use parentheses and exponents and all kind of that stuff, you can plug this into your calculator exactly as you see it. It's going to look exactly like that. Okay? Now, if you want to do it the old-fashioned fun way, then you just are going to follow order of operations. So we're going to do exponents first. -1 squared is a +1. So it'd be 2 times 1 plus 4 times -1. 2 times 1 is 2. 4 times -1 is -4. And then you get 2 minus 4, which is -2. So here's the thing. When I plug a -1 into my function, it spits out -2. So my vertex is at -1, comma -2. -1, comma -2. That's where my vertex is. That's where my parabola is. Okay, now the next thing I need some more points. Right, because I know that that's where my parabola is at, but here's the problem. I don't really know if my parabola goes up or if it goes down. And that's pretty important. And even so, even if I knew that it went up, I'm not really sure if it's like a super wide parabola or maybe a super skinny parabola. I don't know that because I need some more points. I need some points to the left of my parabola, and I need some points to the right of my parabola, which is where this table comes in. Now, here's another super important thing that we're going to talk about. That vertex is the center of my parabola. So hopefully it should make sense that you're going to take that vertex and you're going to plug it into the center of your table. So I'm going to take that -1, -2. That's a solution of my function, but I want to make sure I plug it into the center of my table. That is going to be very, very helpful, I promise you. Okay? Now remember, what I need some points over here. Okay? Because I need to know if this goes up or if it goes down. So here's the thing. I know what happens when I plug in -1. I need to know what happens when I plug in -2. What happens when I plug in -3. So in our table, we're going to plug in -2 and -3. You're just going to start at your vertex, and you're going to go to the left. And then it's the same thing over here. If I want to know what happens on this right-hand side of my parabola, I know what happens when I plug in -1. I need to know what happens when I plug in 0. And I need to know what happens when I plug in 1. So we are going to plug in 0 and 1. So once you do your table, once you plug in your vertex, you're just going to fill in the numbers around that x coordinate. Okay, see that? So if, like, if this was a 5, you do 4, 3, and then 6, 7. Right? Just kind of go up and down. Okay, does that make sense? Okay, now, the next thing I need to do, I need to plug these numbers in. But here's the good news. You don't actually have to plug in all 4 of these. Okay? Let me show you why. Let's plug in 0. Because 0 is a super, super easy number to work with. So keep in mind, when I'm plugging something in, this is like your function machine. So we're going to plug in 0. We're going to follow that rule, and it's going to spit something out. Okay, so y equals, we are going to do 2 times, instead of x, we're plugging in 0 plus 4 times 0. 0 is always super easy to work with. We're going to find that out. 2 times 0 squared plus 4 times 0. That's going to be 0 plus 0. That's going to be 0. So when I plug in 0, I get out 0. So I have another point. I know now that my parabola, right, comes up and over here. Here's the thing. Here's where the good news comes from. This parabola is symmetrical. Is that what the axis of symmetry is? So if my parabola comes up and out this way on the right-hand side, guess what it's going to do on the left-hand side? It's going to come up and out on the left-hand side as well. And when you plug in -2, guess what you're going to get? You're going to get 0. When you plug in -2, I promise you, you are going to get the same thing. So, when you're doing your table, if you put your vertex in the middle, this parabola is symmetrical. So if you start at your vertex and go 1 step to the left and 1 step to the right, you should get the same answer. You have to get the same answer. Those two are always going to give you the same answer. And even better news, if you start at your vertex and you go 2 steps to the left and 2 steps to the right, guess what's going to happen? You're going to get the same answer. Whenever you plug in -3 and when you plug in 1, I promise you, you're going to get the same answer. You don't have to plug in both -3 and 1. You just have to plug in one of them. And for me, I try to avoid negatives at all costs. So for me, I'm going to plug in 1. So we're doing the same thing. We're using our function rule. So y equals, okay, we're going to do 2 times 1 squared plus 4 times 1. Okay, once again, if you're using a calculator, you can just plug this in one big long string. If you want to do it the old-fashioned fun way, you're just going to use order of operations. So 1 squared is 1. So we're going to take 2 times 1 plus 4 times 1. 2 times 1 is 2. 4 times 1 is 4. 2 plus 4 is 6. So I promise you, if you want to try it, go for it. But if you plug -3 into that function, I promise you, you are going to get out 6. Because it should make sense. It should. Because if I plug in 1 and I get 6, on the other side, if this parabola is really going to be symmetrical, I better get the same number. I better get the same number. Okay, once you have all 5 points, you're ready to draw your graph. You're going to connect all of these into your parabola. It's going to look like that. Okay, a little overwhelming, right? A lot of work for one problem. Okay, we are spending at least 3 days on this. We're going to do this today, and I'm not going to have you do the whole process today. Okay, all you're going to be doing today is doing the vertex and the axis of symmetry. Okay, we're going to add in the rest of it a little bit tomorrow. Okay, but let's go ahead and let's get this. Well, let's go ahead and get this glued in. It's going to be 9.2, and this is graphing quadratic functions. Okay, so first one, and like I said, we're not going to go through the whole process. We are just going to do these first two. We're going to find the axis of symmetry, and then we're going to find the vertex. So our first function we're going to look at, let's do y equals x squared minus 4x minus 5. Okay, so remember, the first thing I need to know is is my parabola over here on the right? Is it over to the left? Is it somewhere in the middle? I need to know what area of the graph it's on. So that's that line that cuts it in half. That's the axis of symmetry. So remember, to find the axis of symmetry, it is a line. It's an x equals, and it's x equals the opposite of b over 2a. Also remember that all quadratic functions are in the form y equals ax squared plus bx plus c. So when I want to find the axis of symmetry, the first thing I need b. So remember, b, that's the number in front of your x term, just your plain x term. So in this problem, my x term is right here, so my b is -4. Now remember though, my formula says to take the opposite of b. So if b is -4, what's the opposite of -4? A +4. So it's going to be 4 over, and then we're going to do 2 times a. Here's the thing. A is the number in front of your x squared. There's not a number there. So it's a 1. Very good. So it's going to be 2 times 2. So it's going to be 4 over 4, which is going to be 1. So your axis of symmetry is x equals 1. Now, what I really encourage you to do, go ahead and draw your axis of symmetry, just like we did yesterday. Draw it as a dotted line. Okay, remember, I now know, okay, my parabola is right here, but I don't know if my parabola is up here at the top. I don't know if it's down here at the bottom. I need to find that vertex. But the thing is, I know my vertex is somewhere on this line, so it has to be at 1 comma something. It has to be, if it's on that line. So I already know half of my vertex. It's 1 comma something. I know the x. I have something to plug into my function. To get my y, we're going to do just that. We're going to drop 1 into that function rule right there. So we're going to do y equals, and we're going to plug 1 into that function rule. So we're going to do 1 squared minus 4 times 1 minus 5. So if we follow order of operations, 1 squared is 1. We can go ahead and multiply 4 times 1 is 4, minus 5. 1 minus 4 is -3. -3 minus 5 is -8. So your vertex is at 1, comma, -8. That's all you're going to do today on your homework. You have 6 problems on your homework, I think. That's all I want you to do is find the vertex and axis of symmetry. We'll come back and do the table tomorrow. Okay? So let's do one more, just finding the vertex and axis of symmetry. Okay, let's do y equals -x squared plus 4. Okay, first thing, we want to find the axis of symmetry. So remember, we need x equals the opposite of b over 2a. Now, you need to be so very careful because the first thing I need is b. And remember that these functions are in the form ax squared plus bx plus c. So to find your b, you're going to find your x term. See the problem? I don't have an x term. I have an x squared, but I don't have an x term. Now, for the last one, I had x squared, and I said the coefficient of x squared is 1, because there's not a number there. But that's not the case here, because if the coefficient was 1, this would say -x squared plus x. There'd have to be an x there. So it can't be 1. It'd be 0. It'd be 0, because if it was 0x, 0 times x is just 0. You wouldn't see that there. So b is 0, so you're going to take the opposite of 0, which is still just 0, over 2 times a. And remember this time, a is the number in front of x. It's going to be -1. So it's going to be 0 over -2, which is just 0. So my axis of symmetry is x equals 0. So if we go ahead and draw that, we know now that my parabola is right there in the middle of my graph. And if the parabola is right there at 0 in the middle of my graph, I know that my vertex is somewhere in the middle of my graph. My vertex has to be 0, comma something. I don't know what, but I know it's 0, comma something. And to find that other something, once you have your x, plug it in, okay? That's what you're going to plug into your function rule right there. We're going to do y equals, okay, now follow the rule carefully. It's not going to be as important for the 0, but it will be tomorrow. We're going to do -0 squared plus 4. Now you have to be careful here because the rule is telling me only to square the x. Only square the x. You're not squaring the negative. You're only squaring the x. Now when you square 0, there's just 0. And you take -0, that's still just 0. So you're going to take 0 plus 4, which is 4. So your vertex is at 0, comma 4.